Hello everyone. Today we will learn how to use SQL Syntax to create custom queries for the DIPPR database. We will be using the Microsoft Access version of the sample database for this tutorial. If you need help with a different environment, such as SQL Server Management Studio, please refer to our other videos. Feel free to follow along a DIPPR database of your choice during this video if you'd like. Before you can get started making your own custom SQL queries for the DIPPR database, you'll need two things. One, a copy of your database of choice, and two, the schema diagram for your database. The schema diagram can be found in the documentation section of each release, and it is a crucial tool for making effective queries. Here is what the consolidated schema looks like, which is the schema that's used by most DIPPR databases. However, if you're using DIPPR, for example, or if you're using Access, which is what we'll be using today, or any other database that has legacy in the name, then you'll need to use what's called the legacy schema right here. You can find this legacy schema in the documentation for DIPPR. As you can see from the schema, the DIPPR database is a collection of different data tables, such as the cheminfo table, which contains basic information on each chemical in the database. Here's what the cheminfo table looks like. This table is made up of a lot of different rows and columns. Each column represents a different type of data, and each row represents a collection of data of that type. A database query allows you to choose which columns you want to view data from, and then compiles those columns into a results table. It also allows you to specify conditions on the rows that should appear in that results table. Now, in order to run your own SQL queries, what you'll do once you're in your Access database is you'll go up here to Create, and you'll move over here to Query Design. And then you'll come down here to the bottom right-hand corner and click on this SQL button, which will pull up this window. In this box, you can put all the SQL syntax, all the logic, everything that you want to be in your query. And then once your query is ready, this Run button will be highlighted, and you can hit that and run the query that you want to run. Let's go over some basic SQL syntax. A simple SQL query often has three parts or clauses. First, there's a select from statement, which tells the program which data columns you want to view and which data table contains those elements. Then there's a join statement, which allows you to view data from columns in more than one data table. And then there's a where statement, which allows you to input logical filters on which data you want to see. There's a fourth option that you can include if you so desire, which is order by. This allows you to take your results table and sort all of the rows by whatever you want. So for this example, let's build towards a query that gives a results table that contains the chem ID, name, family, accepted melting point, and the error of that melting point value for all chemicals in the database, and have it be sorted by chem ID. Let's start with our select from statement. In a select from statement, the select portion tells the program which columns you want to see, and the from portion tells the program which table you want to see those columns from. For instance, let's say that I only want to see DIPPR IDs, names, and family for compounds in the cheminfo table of this database. In that case, I would type in the following. I'd say select chem ID, name, and family from cheminfo. As a side note, if you're ever confused about where you need to have capitals and where you need to have things like underscores, it's really handy to be able to reference your schema diagram, which tells you exactly how to spell every table and column name that you need. It's really important to be able to spell everything right so that the program knows exactly what you need. And let's run our query. Here's our results table. And if we scroll down and view all of the data, you can see that there isn't really any particular order to this data. That's intentional. By default, SQL will not sort your data. In order to have our data sorted, what you will do is you'll add in an order by statement at the end of your query. If we want to have it sorted by ChemID, then we have it sort order by ChemID, like this. Now, when we run our query, then we will see that it will be sorted by ChemID, like so. Now, let's go back, and let's say I want to see not just part of the cheminfo table, these 3 columns, but we want to see all of the table. In that case, you would say select asterisk from cheminfo. Now when we run our query, we can clearly see that every column from the table is included in our results. Now, displaying information from the cheminfo table is handy, but it's not particularly useful all on its own. We said earlier that we wanted to get melting points, but there are no melting points in the cheminfo table. So we need something else to get the results that we want. Thanks to our policy and procedures manual, we know that DIPPR stores the melting point as a constant property with property ID MP. Now, if we use the schema diagram, we can see that constant property values are stored in the const values table with const value. But we can also see that the const values table doesn't contain any information on the name of a chemical. So somehow we need to pull information from both tables at once, from const values and from cheminfo, so we can get the name. The best way to do this is with a join statement. A join statement links data from 2 or more tables in a useful way. Now, there are several different types of joins. However, for the scope of this video, we will focus on the left join, which is quite versatile and sufficient for most needs. When you're working in Access, the general format of a join statement is as follows. You type from, and the table name A, then left join, table name B, and then on table name A dot column A equals table name B dot column A. Now in the case of the DIPPR database, this column A usually represents a column that is shared between 2 tables. This is called the primary key foreign key pairing. These pairings are represented with lines between 2 tables in the schema diagram. For example, we can see that in the cheminfo table, there's a line between ChemID here and ChemID and const values. What the join statement does is it finds all rows in table name A here that contain data in column A. Then it finds all the data in table name B that also contain data in the shared column A. Then the join attaches the rows from table name B to rows of table name A that each contain the same value in column A. Let's look at an example. Say I want to left join the const values table to cheminfo table so that I can see chemical names and their constant properties in the same table. To do so, we will add the following to our SQL query. Say select ChemID name family from cheminfo, left join const values on cheminfo.chemid equals const values.chemid. So this tells the program that our 2 tables are cheminfo and const values, and the shared column is ChemID. The program will then attach rows from const values to rows in cheminfo that share the same ChemID. Now, if we were to run our query at this point, we would get this error. The specified field ChemID could refer to more than one table listed in the from clause of your SQL statement. What this is saying is that now that we've introduced both of these tables, there's a bit of a problem when all we say is just chem ID as a column, because chem ID shows up in both chem info and const values. So we need to tell the program specifically which chem ID we want it to pull. And for our purposes, let's tell it to pull the chem ID column from the chem info table, here and here. That should fix the problem. And there we go. The query runs like it should. Let's go back and let's add in a few columns. We also want to view the property values for the chemical. So let's add in the property ID and const value columns from the table to our select statement. Okay, let's run it again. And here we go. We now have our property ID and const value columns. So as you can see in our results table, we have a lot of different values for the constant properties associated with each chemical. But we don't just want to see all the different property values, we want to see accepted melting point values. And we'll talk about how to get just the melting points in a little bit. But first, let's get acceptance into the results table. Looking at the DIPPR Database schema here, we can see that the acceptance column is contained in the sources table right here. There's the acceptance column. So we'll need to join in the sources table as well. To do that, we will use another left join on the source ID column of both the const values and sources data tables as follows. Go back to our query window and we will do this. Put in parentheses, since we're using Access and we're using a second left join, parentheses around our first left join. And then we'll add on left join sources on const values but source ID equals sources dot source ID. Again, this join statement specifies the table that we want to join as well as the shared column that the program will use to match up rows. Now let's add in the columns that we want to get from the sources table, namely acceptance. And if we go back, we can also see that the error column is also in sources, which we also said that we wanted from the beginning. So we'll add in error as well. Let's run our query. Perfect. We have our acceptance and our error columns added on to our results table. Now that we joined all the data tables that we need to access our information, let's tell the program what we're specifically looking for with a where statement. The where statement is the place we can use logical operators to tell the program what data to show from our selection. A general form of a where statement is the following. Where logic statement is equal to true. So any rows for which this logic statement is equal to true will be displayed in our results table. We can use logical operators like and, or, and not to create a very robust where statement. The where statement will allow us to specify that we only want to see melting points in our results table. So let's add the following where statement to our current query. Put it before our order by. Let's say where property ID is equal to MP. We know that we'll want to use the property ID column here, since that labels which property is described by the rows data. And then thanks to my policy and procedures manual, I know that the property ID of the melting point is MP. Property IDs like MP are stored as text in the database. So we'll put MP in single quotes in our query to tell the program we're looking for specific text. Now let's go ahead and run our query. And as you can see, we have our property ID column and all of the values are MP. So we know that these are all melting points here. Now let's get even more specific. Let's go back to our query. We know that we are looking for the accepted melting point, not just the melting point, but the accepted melting point. And from my policy and procedures manual, I know that acceptance is marked with the letter A in the acceptance column of the database. So now we can add on to our where statement by saying where property ID equals MP and acceptance is equal to A. So this will give us rows where the property is melting point and it's an accepted melting point. And that's what we get. All the values are melting points and the acceptance is labeled with A, which means they're all accepted melting points. So this is the information that we originally wanted from the beginning. So when using these statements on their own, you will almost always use them in this order. Select, from, join statement, then where, and then finally order by. Lastly, if we want, we can go to export this to Excel to make it more easily accessible for other endeavors we may have. We'll go ahead first and we'll save it. Give it a name. Nothing fancy. And then we'll see that it shows up here in the sidebar, which means that it is saved. Then we can go to external data and we can hit this Excel button to export it to an Excel spreadsheet. This will allow us to create an Excel workbook with our data in it. And that's all for today. As always, if you have any questions or feedback about Diadem Elite, please feel free to submit a ticket to support DIPPR at byu.edu and we'll do our best to get back to you as soon as possible. Thanks.